The story of silver is far older than modern banking, the stock market, or the global economy. For thousands of years, silver was money, wealth, jewelry, and a symbol of stability in a changing world. But today, something very different is happening. Silver is no longer just stored in vaults or minted into coins. It is being quietly consumed, absorbed, and permanently locked away inside billions of devices that run our modern digital world. And for the first time in history, the amount of silver humans use in technology is not just increasing. It is accelerating at a pace that few people, even within the financial world, fully understand. The technology that powers our daily lives is slowly eating the world's silver supply, gram by gram, product by product, device by device. This is the story of how silver went from the world's oldest form of money to the world's most silently consumed industrial resource. It is the story of how smartphones, solar panels, electric vehicles, medical devices, satellites, and data centers are transforming the silver market without most people even noticing. It is the story of how a metal once stored safely for centuries is now being used in tiny amounts scattered across products that are almost impossible to recycle. And it is the story of why the silver supply-demand balance has quietly shifted into a long-term deficit that experts say may define the next era of global technology and industry. To understand how we reached this point, we must start with silver's most important physical property, conductivity. Out of all 118 elements on the periodic table, silver is the single best conductor of electricity and heat. Nothing else even comes close. Copper comes second, gold comes third, but silver sits at the top. This is not a theory, it is a measurable scientific fact. And as the world becomes more electrified, more digitized, and more dependent on high-performance circuits, sensors, and energy systems, the demand for superior conductivity increases with it. For most of history, silver's conductivity didn't matter much. People valued it for beauty, stability, and monetary trust. But in the early 20th century, the rise of electronics changed everything. Radios, telephones, early computing systems, and military communication equipment began using silver. At first, the amounts were small, but as technology evolved, first slowly, then explosively, silver became essential. Today, silver is inside almost every modern device you can imagine. Smartphones contain between 0.25 and 0.35 grams of silver each. That sounds tiny until you realize that more than 1 billion smartphones are produced every year. Each one contains silver. Each one ends up in landfills or drawers. And each one becomes nearly impossible to recover. Laptops, tablets, smartwatches, televisions, and gaming devices also rely on silver-based components. The modern computing world cannot function without silver because no other material carries electrons with such low resistance. It allows faster data transfer, cleaner signals, more efficient energy use, and smaller, lighter components. But while consumer electronics were the first wave of silver consumption, they were not the last. In fact, they are no longer the biggest. A new technological revolution is consuming far more silver than anything before it. That revolution is clean energy, specifically solar power. Solar panels are the single largest industrial source of silver demand today. Each solar panel uses a layer of silver paste that helps transport electrons generated by sunlight. As nations shift toward renewable energy, solar installations are expanding every year. The International Energy Agency projects global solar capacity to triple in the next decade. That growth requires massive amounts of silver, thousands of metric tons per year. Solar demand grows not because of speculation, but because governments and corporations have legally committed to long-term renewable energy targets. Analysts widely agree that silver demand from solar technology alone may double even under conservative forecasts. This brings us to one of the most important and least understood realities of the silver market. Once silver is used in electronics or solar panels, it is extremely difficult to recover. High-grade, pure silver bars can be stored forever. But tiny particles of silver embedded in circuits, solder, and chemical pastes are scattered across the world in billions of devices. Recycling these micro-quantities is technically possible, but economically unviable. It costs far more to extract tiny atoms from discarded electronics than it does to mine new silver from the earth. Silver stored in vaults, exchanges, and private holdings. But those inventories are shrinking. Industry consumes silver faster than new supply comes online, and technology is accelerating this imbalance. This is not a temporary trend, it is a structural one. The next major technology consuming silver at unprecedented levels is the electric vehicle industry. EVs contain up to 50 grams of silver each, significantly more than traditional gasoline cars. This is because EVs rely heavily on complex electrical systems, charging components, inverters, battery management systems, and advanced driver assistance technologies. As governments push for widespread adoption of electric vehicles, silver demand from the automotive sector rises with it. The growth trajectory of the EV industry is one of the strongest in the entire global economy, and silver is a core ingredient in that growth. Medical technology is another silent silver consumer. Silver is used in antimicrobial coatings, surgical instruments, wound dressings, hospital filtration systems, and diagnostic equipment. Its natural antibacterial properties make it invaluable in modern healthcare. Demand from the medical field does not fluctuate with market speculation. It grows with population and healthcare expansion. And then there is the unseen world powering the digital economy: data centers, cloud storage facilities, networking equipment, servers, and communication hardware all rely on silver-based components. The global shift toward 5G technology, artificial intelligence, machine learning, to small connectors that allow electrical impulses to travel instantly across systems. Even the global financial system itself, credit card networks, digital payments, stock exchanges, automated trading platforms, runs through servers and communication equipment that rely on silver. If you step back and look at the big picture, a pattern becomes clear. Every major technological megatrend relies on silver. Clean energy, electric vehicles, digital transformation, cloud computing, advanced electronics, AI, medical systems, and global communication networks all depend on this metal. Silver is not in competition with technology. It is the fuel behind it. But here is where the story becomes even more important. Silver supply is not keeping up with this wave of technological consumption. Global silver production has been relatively flat for years. Large mines are aging, ore grades are declining, and new discoveries are scarce. Silver is often mined as a byproduct of other metals such as copper and zinc, meaning its supply is tied to the economics of those markets. Even if silver prices rise, mining companies cannot instantly increase output. A new mine can take 10 to 15 years to plan, permit, finance, and build. In other words, the supply response is slow and highly constrained. Meanwhile, demand is rising in industries that cannot simply reduce usage. Solar manufacturers cannot replace silver with cheaper materials without reducing panel efficiency. EV companies cannot switch to inferior conductors without sacrificing safety or performance. Medical equipment requires silver's antibacterial qualities. Data centers demand reliable conductivity to handle increasing processing speeds. These industries cannot pause, shrink, or substitute easily. Their growth is locked in. This creates a long-term structural imbalance that few people understand. The world is using more silver than it produces. Technology consumes silver in ways that permanently remove it from circulation. Industrial demand rises faster than mining supply. Above-ground inventories shrink year after year, and the industries that use the most silver are among the fastest-growing sectors of the global economy. The question is not whether silver demand will grow. It is how the world will adapt when technology consumes more silver than the mining industry can supply. Some analysts argue that recycling will eventually solve the problem, but recycling small amounts of dispersed silver is extremely difficult. A solar panel may last 25 years. By the time it reaches the end of its life cycle, the silver inside is so thin and so integrated into the panel structure that recovering it is nearly impossible. The economics simply do not support it. Most silver used in electronics is lost forever. Recycling may improve, but it will not match the accelerating pace of consumption. The next issue is geopolitical. As nations compete for technological dominance, securing access to critical materials becomes a strategic priority. Governments have already implemented export controls on rare earth elements, lithium, graphite, and other essential materials. Silver could easily enter this category. Nations with silver reserves may restrict exports. Nations without silver may scramble to secure supply agreements. As competition intensifies, the global supply chain becomes more fragile. This means that silver's new role is not only economic or technological, it is strategic. Another factor is the shift toward physical silver in investment markets. For decades, silver was traded mostly through paper contracts and financial derivatives. These instruments allow large volumes of silver to be traded without physical metal ever moving. But in recent years, more investors have shown a preference for physical silver over paper silver. When more market participants request physical delivery, pressure increases on vault inventories. The mismatch between physical supply and paper claims becomes more noticeable. This pressure does not always result in dramatic market events. It often shows up quietly, higher premiums, delivery delays, shrinking exchange inventories, or increased volatility during supply chain disruptions. The deeper story, however, is simpler. Technology is consuming silver faster than the world can replace it. And unlike many industrial materials, silver is simultaneously a monetary metal. It is used for savings, investment, and wealth storage. This dual nature, industrial necessity and monetary value, makes silver uniquely sensitive to global economic shifts. When technology demands more silver, the market tightens. When investors demand more silver during periods of uncertainty, the market tightens further. When both forces operate at the same time, the entire supply chain becomes strained. This raises an important question. If silver is so essential, why is the world not talking about it? The answer lies in the structure of modern technology. Silver is used in small amounts per device, making its consumption invisible to most consumers. People do not see the silver inside their phones, laptops, cars, or solar panels. It is not advertised or marketed. It is hidden, built into microcomponents and chemical pastes. The metal that enables modern convenience is almost entirely invisible. Another reason is psychological. People often assume that abundant minerals are always available, but in reality, many natural resources face long-term constraints. Silver is one of them. Geological surveys show that high-grade silver deposits are becoming rarer. Many of the world's largest silver mines are aging. New discoveries are difficult to develop, and as environmental and regulatory standards increase, mining becomes more complex and expensive. The next major challenge is energy. Mining silver requires significant energy, transportation, and processing infrastructure. As global energy systems transition toward renewable sources, mining operations face both opportunities and challenges. Some mines may reduce emissions, but others may face higher operational costs. This dynamic further influences long-term supply trends. As we look ahead, silver's role in the global economy becomes even more significant. The future is electrical, digital, renewable, and interconnected. All of these transformations require silver. If technological growth continues, silver consumption will remain high. If technological growth accelerates, silver consumption will explode. It is no exaggeration to say that the world's technological future is built on silver. Data networks, consumer electronics, electric mobility, clean energy, communications, healthcare, space exploration, and industrial automation all depend on it. It is a pillar of the modern world, as if it were abundant and easily replaceable. There is no perfect substitute or chemical stability, but it is inferior for high-performance needs. Silver remains irreplaceable. This leads to an important reality. A bottleneck resource is one technology can only expand as fast as its slowest essential component. The renewable energy sector slows down. Electric vehicle production slows down. Advanced electronics slow down. Communication networks slow down. A world that depends on electrification cannot outgrow its supply of the metal that makes it conductive. We are living through the early stages of this bottleneck. The signs are visible. Rising industrial demand, falling above-ground inventories, constrained mining supply, soaring solar installations, expanding EV production, increasing data center construction, and rising investor interest in physical silver. When you connect these dots, the picture is clear. The technology that defines the future is consuming the metal that defined the past. The silver market is not experiencing a temporary cycle. It is entering a long-term structural transformation driven by forces larger than any investor, government, or financial institution. This transformation is not built on speculation, but on engineering, physics, and global economic trends. The most important takeaway is this. Silver's future is defined not by its price, but by its utility. Price charts can rise and fall, sentiment can shift, economic cycles can come and go, but the physical demand for silver and essential technologies is permanent. As long as humanity continues to advance technologically, silver demand will remain strong. The second takeaway is that silver's supply limitations are real. Unlike software, silver cannot be programmed into existence. It must be mined, refined, and transported. It must be physically extracted from the earth. There is no shortcut. The third takeaway is that silver's role in the global economy is changing. It is no longer just a precious metal. It is a strategic resource, a technological foundation, and a critical component of the future energy landscape. As more people begin to understand this shift, the perception of silver will evolve. Companies will secure long-term supply agreements. Governments may consider strategic stockpiles. Technology manufacturers will adjust their procurement strategies. Investors will treat silver not just as a hedge, but as a necessity. The technology that is quietly consuming the world's silver is not slowing down. It is accelerating. And as it accelerates, the world's understanding of silver must evolve with it. The future will be shaped by many forces: innovation, energy, policy, economics, and global competition. But beneath all of these forces lies a simple truth. Every circuit, every electron, every panel, every device, and every digital connection depends on the same metal.